Okay, full disclosure here. I did this in a hurry, and I think I got almost everything wrong about this, except for B. I just carefully went on and on. Okay, so a solid sphere is released from rest below the surface of a fluid and begins to fall. Now, see, here I thought it was moving, right? So I'm all like, but okay. But draw and label the forces acting on the sphere at the instant when it's released, right? Okay, so what we've got to infer here is that initial velocity is zero, okay? Because remember, a object moving through a viscous fluid, there's going to be a drag force on it if it's moving, right? It's going to be, what is this? It's 6 pi nu rv, right? We're going to have a buoyant force that could possibly be acting on it, right? And that is rho volume of that sphere, rho of the fluid, right? Times g. And then you're also going to have the weight, right? The force of gravity, which is going to be the mass times g, right? Okay, these are all possibilities, but if the initial velocity is zero, and this is, of course, I didn't read the problem carefully enough, right? If that initial velocity is zero, then this force isn't in the picture, right? So basically, you have this object at rest. It hasn't begun to fall yet, and so these are going to be the forces. So label which direction the buoyant force is, label which direction the force of gravity is. Now, remember, it's falling through the liquid. This means it's more dense than the liquid, right? So one of these forces is going to be bigger than the other. So make that arrow longer, okay? So the buoyant force indicate which way that is, the gravitational force, right? And by the way, don't just call it gravity. You have to say force of gravity, okay? They get really annoyed when you say gravity. For me, the gravity would be good enough, okay? But you need to say force of gravity because maybe gravity could be confused with the gravitational field strength, okay? Maybe, I just don't know. Okay, so say force of gravity, okay? Label this guy force of gravity, label this one the buoyant force, and put them in the right direction. Okay, explain why the sphere will reach a terminal speed. Well, okay, so you've got these forces acting on it, right? Okay, and the reason it's going to reach a terminal speed is that the difference in force is down, and it's going to start moving down, but this is going to exert an upward force on it, and that upward force is going to increase as the velocity increases, and at some point it can't go any faster through the fluid, right? That's the kind of argument you need to make, okay? All right, so let's look at C. Spoiler alert, I'm going to have to spoil the answer to A for you to talk about C, right? Okay. So the weight of the sphere is 6.16 millinewtons, right? So that is the force of gravity is 6.16 times 10 to the minus third newtons, right? So milli just means 10 to the minus third, just like milliliters or millimeters or whatever, millinewtons. And the radius is 5 times 10 to the minus third meters. For a fluid of density, that's 850 kilograms per cubic meter, the terminal speed is found to be 0.280 meters per second. Calculate the viscosity of the fluid. We can do this, right? Okay, so as this thing falls, right, we've got the buoyant force up, we've got the drag force up, and then we've got the force of gravity down. Okay, so the force of gravity is going to equal, at terminal velocity, as this thing is moving at terminal velocity, right, that gravitational force will equal the buoyant force plus the drag force, right? Okay, so now we just have to plug in things here, right? The force of gravity is going to be this, right? So we'll plug that in. We'll go force of gravity is equal to, and then our buoyant force will be rho of the fluid, right? Times 4/3 pi r to the third, right? Times g. Okay, and then plus the drag force, right, which is 6 pi, is that nu? I can't remember, r v, right? So here's our velocity. We're going to plug that in. This is our radius. Plug that in there. Nu is, of course, what we're trying to solve for. G, we know what G is. That's 9.81. We're going to plug the R in there as well. Density of the fluid is that, right? And then the weight, the force of gravity is that, Okay. The only thing you don't know is that viscosity. And I'll give you a clue. It is somewhere between 0.06 and 0.07. Okay. See if you can figure out what the units are too. Okay. The units are interesting. But anyway, I think that's all there is for this one. Okay.